Hello students, welcome to YouTube channel Vidya for Success. Dear students, in this video, let us understand how to solve problems concerned with standard normal distribution. Before attempting to solve any of the problem, let us understand how to find the value for a shaded area in a standard normal distribution. Please notice here I have considered a normal curve. Okay, so here if we are asked to find a x value, for example, if you have been asked to find what will be the probability of a standard normal variate, that is z, taking value greater than -2. So here I have shaded the area. So here we have been asked to find the x taking the value greater than -2. Nothing but this complete area comes under the curve. This I need to find this area. So if I need to find this area, then I will be taking the help of a distribution table, that is standard normal distribution table. So the normal distribution table looks like this. So here I would like to find the area from -2 to infinity. So here nothing but I will be looking what is the area, that is the shaded area under this curve, where z value is -2 and it will go up till infinity. So I will be looking into this area value. So z is -2. So -2 here. From -2 up till infinity, so the value is 0.9772. So this is the answer. Okay, so if we are been asked to find the value of z ranging from minus value, from negative up till infinity, then we will be looking the value in this particular distribution chart. Okay, that is a statistical chart which will help us to find what is the area under the curve for a particular z value to infinity. Okay, similarly, let us consider one more area under the normal curve. Please notice here the area is towards the right hand side of the mean, that is here the z value is 0. So if you want to find the area from 0 up till infinity, that is positive towards the positive x-axis from 0 up till infinity, then we will be considering the same distribution chart, the normal distribution chart, but here the z values, it ranges from 0.0 up till 3. Okay, please notice here. So for example, if I would like to know what is the area, for example, from 0 to infinity, then the area value is 0.50, obviously, because the line, the straight line from mean towards the curve, towards the top of the curve, it will divide the entire normal curve into symmetry, into two equal halves. So that's why 0.5. Well, on the other hand, if I want to find what is the area from 1 to infinity, then the answer is 0.1587. On the other hand, if I want to know what is the area, let us say 1.25 to infinity, area from 1.25 to infinity, then 1.2 here, the row heading is 1.2, and I need to look out for the fifth column. So the fifth column is here. It's the value, this is a value. So 1.25. So 1.2, row heading is 1.2 and the column heading is 5. So the answer is 0.1056 is the area from 1.25 to infinity. Okay, so this is how we will be finding the value of the area under a normal curve. Now let us take up a first problem. So the first problem here is, if x is a normal variate with mean 64 and variance 144, find the probability. So we have been presented with the mean value. Mean mu is equal to 64 and variance is 144. Okay, and what x is? X is a normal variate. It is not a standard normal. It is a normal variate. What we have been asked to find, we need to find the probability that x is greater than or equal to 67. That's the first question, first condition. Second condition is x lies between greater than or equal to 60 and less than or equal to 66. And the third condition imposed is x is less than 62. So once again, let us discuss this question. if you consider x as a normal variate with mean 64 and variance 144, if you attempt to solve this problem using the normal distribution and the probability density function f of z, then you will not be able to solve this. So because let us say x is greater than or equal to 67, so then x can be 67, it can be 68, 69, 70, 500, 5000, it can be any value. So you cannot find solution using a normal distribution or or else you cannot find the answer for this using probability density function formula. So you need to convert this normal variate, that is x, to a standard normal variate. So x will be converted to z. So what is z? Z is a standard normal variate. Here x is a normal variate. So here we will be standardizing the x normal variate to a standard normal variate, and later we will be finding the solution. So let us start finding the solution. Already we know that x is a normal variate to start with. What is the mean of this normal variate? The mean of this normal variate is 64 and the variance, that is sigma square, is 144. But here I have kept, instead of considering 144, I have kept it as 12 square. What is the reason? Because to work with, I cannot work with a normal variate. I cannot find the answer for this question. So I need to convert, I need to standardize the normal variate to a standard normal variate. For that particular process, I will be going with the mu value, that is mu mean is 64, I will be keeping 64 as it is, but I need to know what is the sigma value, because if I want to convert this normal variate to a standard normal variate, that here z is a standard normal variate, to convert that I need sigma value. I don't want sigma square value. What is sigma square here? Variance value is 144. But I need sigma value. So 144 is a sigma square value. So then what is sigma? Sigma is 12. Okay, you can understand this. Now, so then if at the during the process of standardization, then z is equal to x minus 64 by 12. This is nothing but x minus mu by sigma. Okay, so here what is z? Z is a standard normal variate. When it will become standard normal variate? When mu becomes 0 and standard deviation is 1. So here z is equal to x minus mu value is 64 and the sigma value is 12. Okay, so now z is a standard normal variate. Okay, next, later on. So what we need to find? What is the first question? We need to find what is the probability of a normal variate x taking value greater than or equal to 67. It can be 68, it can be 69, 500, 5000, it can be any value, but you cannot find it using normal distribution. So that's why we have converted it into a standard normal distribution. So now probability of x greater than or equal to 67 is equal to, I can write like this, probability of z, I am converting x to, that is normal variate will be converted to a standard normal variate. So what is z? Z is equal to x minus 64 by 12. Here 64 is mean, 12 is the standard deviation. Okay, so here z greater than or equal to 67, in the place of x I am replacing with 67. 67 minus 64 by 12. That is nothing but probability of z greater than or equal to 67, like this. Okay, so that is, if you simplify this, you call this complete term as z greater than or equal to 67 minus 64 is 3. 3 divided by 12 is 0.25. So we need to find the probability of z, the standard normal variate z, taking value greater than or equal to 0.25. Nothing but I need to find the area from what? 0.25 to infinity. Let us understand it using the normal distribution curve. Please notice here. So this is the complete curve under area under the curve. Okay, what I need to find? I need to find area from 0.25 towards infinity. I need to find this complete area. I am moving in this direction towards positive x-axis. So I need to find the probability of the standard normal variate z taking value greater than 0.25. So greater than, towards the infinity, not towards this side, towards greater than 0.25, greater than or equal to. So complete this area I need to find it. Okay, so how to find this? So for this we'll be doing simple computations. Please notice here. So we need to find area from 0.25 up till infinity. So that is how we'll be using the table. So already I've shown you a table. So in that particular table you need to study the table. You need to go through the column Z value 0.25. Nothing but you'll be finding a row with the heading 0.2, and corresponding you need to check out the fifth column. So there you will be finding the answer 0.4013. So 0.4013 is the area, is the chance that a standard normal variate Z will be greater than 0.25, or else you can say that 0.4013 is the probability that a normal variate X will consider value greater than or equal to 67. Now let us work on the second condition. So here we need to find probability of X, normal variate X taking value greater than or equal to 60 and less than 65. So what we are doing, we will be converting the normal variate to a standard normal variate. So what is the procedure? Here is the standard normal variate Z. Okay, X minus mu by sigma. Mu is 64, sigma is 12. Okay, so here this is the lower limit is 60, upper limit is 66. So here 60 minus 64 divided by 12. Similarly on the upper hand side 66 minus 64 divided by 12. So after simplification we need to know what is the probability of the standard normal variate Z taking value greater than or equal to minus 0.33 and less than 0.17. So you got this value after simplification. Okay, please notice this. So we need to find this area. So what is the area? It lies between minus 0.33 and less than 0.17. So this is the shaded area we need to find. What is this particular area? We need to find it out. Okay, so area from minus 0.33 to 0.17. So how to find this area? So we can make use of the statistical table. Okay, we are having a normal distribution table. We can make use of that. First of all, we need to decide from where we need to look it out. Okay, so we need to look out area from 0.33 to infinity. So from here up till here, first of all we will know what is the value, and later we can easily subtract from here to here. We can subtract, do the subtraction. So first we will find area from minus 0.33 to infinity. From this area we will subtract area from 0.17 to infinity. Okay, so what is the area from minus 0.33 to infinity? That is 0.6293. And what is the area from 0.17 to infinity? This complete area is 0.4322. So if you do the subtraction, then you will be getting the value as 0.1968. So this is the area. So 0.1968 is the area from minus 0.33 to 0.17. Okay, so this is the answer for the second condition. Next, third condition, we need to find probability of the normal variable X taking less than 62. Okay, so now we are standardizing, going for standardization. So we will be converting it into a standard normal variate. So probability of X minus 64 divided by 12 less than 62 minus 64 divided by 12. So after simplification we need to find what is the probability of the standard normal variate Z less than minus 0.17. So let us take out the help of the chart, normal curve here graphically. So we are looking for Z less than minus 0. Less than means this particular area, this side towards minus infinity. So this the area we need to find, this area, complete this area we need to find out. Okay, so that is area from minus infinity to minus 0.17. Okay, we will be finding the area from minus infinity to minus 0.17. So how to find this? Very simple. So we know the area from minus infinity to infinity. This is 1, isn't it? So the total area under the curve is 1. We know that area. So from this complete area, let us subtract area from here up till here. Okay, so nothing but area from minus infinity to infinity is 1 minus area from minus 0.7 to infinity. So that is 1 minus 0.5675. So this is the area. Okay, we will be subtracting this area from the complete curve area. So the answer is 0.4325. So 0.4325 is the area, shaded area is the value. Okay, so this is how you are going to solve the problems under standard normal distribution. So with this, I am winding the video. Thank you.